So, organic compounds, the bonding characteristics of carbon contribute to its stability and allow it to be the foundation of organic molecules. So, organic molecules really is anything containing carbon. If it contains carbon, you are organic. Right? So, the characteristics result in a large variety of structures. So, organic compounds are most famously known as DNA, RNA, amino acids, really your large biomolecules that you guys learned about last year. All of those are organic compounds. So carbon-based compounds include hydrocarbons, which we've learned before, things that contain carbon and hydrogen. What are hydrocarbons famous for? Whenever we talk about hydrocarbons, what are they usually doing? Reacting how? Combusting. Right? Those are your fuels. Small carbon-containing molecules with functional groups, we'll talk about those. Complex polymers, right? DNA, not amino acids, but DNA is a polymer. What else is a polymer? Proteins are polymers. The nylon that your clothes are made of, that's an organic polymer, things like that. And then your biological molecules. So petrochemicals contain hydrocarbons, so propane, butane, octane, right? What do we use propane for? Gas in your grill, right? When you go to the gas station, what are you pumping into your tank?
Octane.
No, not octane. Some octane. Methane and ethane. Right? It's a methane-ethane mix. Right? Those are things that combust to give you power. So that's what a petrochemical is. So there are 3 types of organic compounds. So all organic compounds must contain carbon. Right? That is what defines it. So they are given the root name alk. Okay? That tells you that you are organic, alk. Now, the types of bonds, so single, double, or triple, linking the carbons determines the type of organic compound. So you have alkanes, right? Alkanes are single bonds. So think about it this way, when someone's walking with a cane, right, that cane is a single bond. Alkenes are any double bonds. I don't have a good mnemonic for that one. If you come up with one, let me know.
You say you have 2 knees, and that kind of looks like one knee.
That's what I saw.
Oh, okay, I like that. So alkenes are like knees, you have 2 of them. Then alkynes are triple bonds, and there are all kinds of people in the world. That's an alkene slapper. Oh God, I gotta stop. Alright, so alkanes are single bonds. Alkenes is if it has any double bonds. Alkynes is if it has any triple bonds. So looking at these, alkanes contain only single bonds. So here we have methane, all single bonds. Ethane, single bonds between the carbon. Propane, single bonds. Butane, all single bonds. So these molecules are said to be saturated because the carbon atoms are surrounded by the maximum number of hydrogen atoms. Each one of these carbons is saturated with single bonds. So the formula for an alkane is going to be Cn. That N just represents any number. And then H, 2N plus 2. So what that means is if I have 1 carbon, then how many hydrogens will I have? 4, right? 1, 2, 3, 4. If I have 3 carbons, how many hydrogens will I have? 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So from just the formula, that is how you can recognize an alkane. Now alkenes, right? Are alkenes? Wow, I can't talk. Alkenes contain any double bonds between 2 carbon atoms, even if the rest of them are single. So here's ethene, there's a double bond. Propene, you see this is a single bond, but it has a double bond. Butene, single bonds, but it has a double bond. So these are unsaturated because some of the carbon atoms do not have the maximum number of hydrogen atoms. So these 2, right, these 2 carbons are unsaturated. What about this one? This carbon would be saturated or unsaturated? Saturated. This one? Saturated. It's just these 2 that are unsaturated.
Is this given to me because I'm supposed to have this? Number 41, someone wrote it on there.
Yes, somebody wrote it on there. You are supposed to have it. So for an alkene, it's going to be CnH2n. So if I have 3, how many H's do I have? 6. 1, 2, 3, 4, 5, 6. Oh. Now alkynes have any triple bonds. So here there's a triple bond, triple bond, triple bond. So looking at this propine, sorry. Right? Is this carbon saturated or unsaturated? Unsaturated. This one? Unsaturated. This one? Saturated. So for this, for Cn, H is going to be 2n minus 2. So alkanes are plus 2, alkenes are just 2n, right? And then alkynes are 2n minus 2. So here's a little organic suffix way to remember this. So ending in ane, you have single bonds, CN, H2n plus 2. So this will be pretty useful. Know this. Alkanes, alkenes, alkynes. So to name an organic compound, it's similar to naming covalent compounds, right? The number of carbons will give you the root name. So when we did covalent bonding, what was 1? Prefix for 1, mono. What was 2? 3, 4, 5, 6, 7, 8, 9, and 10. So looking at this, really the big ones that are different are 1 through 4. Right? Instead of being mono, you are meth. Instead of being di, you are F. Tri becomes prop. Tetra becomes bute. Yeah, bute, not bud. Bute. Okay. The rest of them, just take off the A.
Okay, I thought that was
So the 4 that you really need to know now are 1 through 4. So meth, F, prop, and bute. So that gives you your prefix, and then the ending is either going to be ane, ene, or ine, depending on the type of bonds you have. So looking at this, how many carbons are there? 3. So what's its prefix going to be?
the last one.
Prop. Prop. Okay. And what type of bonds do we have? All single, so its ending will be ane. So this is propane.
Oh, propane.
Looking at this next one, how many carbons are there? 4, so it's going to be bute. What a bute. All right. What type of bonds? There's a double bond, so its ending will be ene. So this is butene. How many carbons are there? 10.
No.
10.
There are
2, 4, there's 10. There's 10.
Oh. There's not supposed to be 10. Let's pretend there's 9. So there will be 9. What type of bonds? Single, so it ends in 8. So nonane. Really, what is it? Decade. I googled nonane and they gave me this.
You didn't check it?
No, I really didn't.
You can't trust that.
I know, you really can't. All right, this next one, how many carbons? 2, so it will be F. F. And the types of bond? Triple, so it ends in ine. So it is ethine. That's not so bad, right? Actually, organic is even better than covalent naming. Well, until you take AP and then it gets worse. All right, now the next one. I think this is my last one. How many carbons? 5. So it will begin with pent. What type of bonds? There's a double, so it'll end in ene. So pentene. Yes.
Is there ever
You had me.
Yes. That's special naming. We don't do that in this class. Learn it next year. All right, how many carbons? 1, so it will be meth. What type of bonds? Single, so it ends in methane. All right, now, in addition, right, sometimes it's not just carbons and hydrogens. Sometimes you have what are called functional groups. So functional groups are special groups on an organic molecule that have different functions. Okay? So these functional groups get special endings to their name instead of just ane, ene, or ine. So this one is what's called an aldehyde. So an R is just another carbon chain. So pick your carbon chain and stick it on there. So an aldehyde has a carbon chain ending with a double bonded oxygen and a hydrogen. Right? That ends in al. Okay. So something like this, I have two carbons connected by a single bond. So that would be usually ethane. So knock off the E and it becomes ethanal. Alcohols are any alkyl chain, right? So a carbon chain ending with an OH or having an OH on it. So here you knock off the E and then in an ol. So here it's eth because there's two of them, so ethane. Knock off the E because of the OH, you get ethanol. Carboxylic acids, right? That's so what is acetic acid's formula? It's CH3COOH, right? Right. So here, right, you can see, right, there's an alkyl group here, so CH3, and then COOH. Right? It's a structural formula that tells you there's one oxygen and then another oxygen connected to that carbon. So a carboxyl group is a double bonded oxygen with an OH. So that you knock off the E to give it oic acid. So here, right, it's an ethane, so ethanoic acid. This is the same thing as acetic acid. Ethanoic and acetic acid are the same thing. Ketones. Right? Ketones, instead of having an R and then an H, have two alkyl groups connected. So really, somewhere in the middle of your chain, you've got a double bonded oxygen just kind of chilling around. That's ketone. So they end in -one. So here you have propane with that double bonded oxygen, so it becomes propanone. You guys don't have to know these endings. I just want you to be familiar with functional groups and maybe what they look like, just in case you come across them. Just in case.
Just in case.
Just in case.
Like in my life or in this class.
I want you to know what a functional group is. Okay? It's just a special group added on to your alkyl chain. Yeah.
Wait, I just missed it. So what's the difference between carboxylic acid and ketone?
So a carboxylic acid, notice, has the C double bond O with a carbon chain on this side, the R, and then an OH. Okay? A ketone has two carbon chains.
Oh.
An aldehyde has a carbon chain and a hydrogen.
Okay.
Alcohol is its own little thing.
Got it.
So uses for organic compounds. Right? Big one, pharmaceuticals. Right? So aspirin, vitamins, insulin, all of those are organic molecules. So this is aspirin. Now this base right here is a very, very special organic compound. Okay? That is what we call benzene. So benzene, right, is a cyclohexane. Now hex is how many carbons? 6. And what do we think cyclo is going to mean?
Crazy.
It's a ring. So for cyclohexane, I'll do it over here. Okay. So there's a carbon at each end here. Okay. And then there are 3 double bonds alternating on each one, right? And 1 hydrogen coming off of each one. That is a very, very special organic compound that has a lot of special chemical properties about it. Okay, so we actually see it a lot in very large biomolecules. Right? So the structure of benzene was confused chemists for a long time. They couldn't figure out what the structure of benzene was until one guy sitting in his lab thinking about benzene, apparently, fell asleep. And you know how sometimes when you fall asleep, you dream about whatever your mind's been working on? He had a dream about snake. Have you guys, what is it called? I forget. but it's when snakes in a circle eating each other's tails.
I hate
Oh yeah.
I don't.
Yeah.
It's a symbol.
Ain't no symbol. That's
It is a symbol.
It is.
scary.
I don't remember what it's called.
I'll look it up.
No, you won't.
Go ahead, look it up. Anyway, you see, it means like eternity or something like that. Anyway, he dreamt about that, and so he realized benzene is actually in a ring. And then we figured out, based on that, it had the 3 double bonds. So without all this extra stuff attached to it, that is benzene. So some other organic compounds, all of your plastics. Plastics are formed from petrochemicals of very, very long carbon chains. So all of your plastics are organic. Now, biological macromolecules, nucleic acids, proteins, all of those are organic molecules. So here I have a protein, right, with 3 different amino acids, and it's nicely colored. Isn't that nice? So polymers consist of small molecules that link together to make large molecules. So they have repetitive subunits. Right, so natural polymers are your proteins and your nucleic acids. So things like amino acids in a repeating structure. DNA with your nitrogen base and your ACTG. Yes, G. Now there are also synthetic, so human-made polymers. So polyethylene. Right, nylon and Kevlar. The SOL loves to give you a choice to pick out which ones are natural and which ones are man-made, synthetic. So the number 1 natural polymers are proteins, nucleic acids. Pretty much if it's in your body, it's natural, hopefully. Now synthetic, right, are things that you make. So nylon is used in clothes. Does anyone know what Kevlar is?
Isn't that bulletproof stuff?
Yeah, it's used in body armor, Kevlar. Now why would a polymer be good for body armor?
It's very strong.
Right? It's all connected to each other. It's tough to break. It's not something that can tear very easily. It's like a net, a really tightly knit mesh net. So it doesn't break very easy. Another one, when you guys cook, do you know what it's called in the pan, what it's coated in?
Vegetable.
So the non-stick coating on your cookware is called Teflon.
Oh,
right, Teflon. Teflon is a synthetic
Wait, what is Teflon?
polymer.
Use a fry.
So, that is it for organic chemistry.